of 3. Okay, well, I know I have my two brackets here. And I just got to double check, because if I have a number out here, remember that this is something that messes things up a little bit. So we have to be careful with that. So it only has a 1, so we know that's going to be 1x and 1x. And we need to multiply to -4 and add to +3. Well, two numbers that multiply to 4 are going to be 1 and 4. So if I have +4 minus 1, that should work. Okay? And again, if I'm not sure, I check it. I test it by multiplication. Okay, factoring is unmultiplying, so multiplying should get us back to where we started. So it's going to be +4x minus x. That gives me my +3x. -1 times +4 gives me my -4 ones. Okay. So here's another one. This looks like a typo. I just need to fix that. Okay, so it's going to be 4x squared plus 20x plus 24. Okay, so, and I mentioned at the beginning here, the factoring involves all these three types of factoring. So we need to make sure that we factor first. Well, there is a greatest common factor. We need to factor that out. So here, if I take a look at this trinomial, I could try to factor it as a quadratic or try two brackets like this. However, we should not do that because we should always factor our greatest common factor first. So here's a greatest common factor of 4. So when I factor that out, I get x squared plus 5x plus 6. Now that I factor this piece out, I can now look at the remaining factor. In fact, I can factor this into prime numbers, 2 times 2, but we're just going to leave the number part. So we're familiar with factoring numbers anyways. We know the factors involved here. We want to see the factors involved here. So we need to then factor this as a quadratic. Okay, so again, and I forgot to do it for this one, but I'll do it for this one. We have our area. Our area is the quadratic trinomial. The x squared and the 1s goes into this diagonal, and I have to fit the 5x in these two parts. So I have to basically split up the 5x. I'm looking for the split that gives me a product of 6 from here and add up to the 5x here and here. Well, that's going to be 3x and 2x add up to the 5x, and that's going to give me this product of 6. So I'm going to end up with x plus 3 here, x plus 2 here. Okay, so that's got a common factor or side length of x, common side length or common factor of 2. Here has a common side length, a common factor of 3. These two terms have a common factor or common side length of x. Okay, so this is going to be my factored form. I end up with x plus 3, x plus 2, and that gives me my factored form. Now we could further break apart the 4, but again, most of us are quite familiar with the factors of 4, so we can just leave it like that. So this last one here, we're going to factor this. Let's put it in our area model here. Okay, so I know this is going to be x squared, and this is going to be 25. Okay, so we're looking for two numbers that multiply to 25, and we can split up the middle 10x into two parts here. Well, we know that 5 times 5 is going to give us that 25, so we can split up the 10 into 5 and 5. That gives us a side length here of 5, common side length. The common factor here of x squared and 5x is x. So here we have x times x, and then we're going to get x times 5 equals 5. Okay, so everything's consistent with length times width equals area. So we can find the parts by division if we want. If we know the area, we can go 5x divided by x equals 5. So there's lots of relationships there. So when I write this out, I'm going to end up with x plus 5, x plus 5. Okay, so that's my factored form. And when we look at this trinomial, if it's the same length this way as it is this way, what is this shape? Well, it's clearly a square. And if it's a square, we can write it in the squared form. Okay, so square indicates that we're dealing with a square shape. Yeah, we definitely have a square shape here. So we can use a square. We can keep it as multiplication, but there are times where it's more convenient to write it in the squared form.